Okay, hello everyone. I welcome to all in our lecture series on conversion of numbers from one system to another. In this lecture series, we are discussing these topics, which are most essential for B.sc, B.Tech, M.sc, M.Tech, and various entrance examinations. In our last class, we have been discussed decimal to binary and binary to decimal conversion. In this class, we are going to discuss decimal to octal and octal to decimal conversion. Okay, so let us start. Last class, these things we have been discussed: decimal to binary conversion. In detail we discussed fractional decimal to binary conversion. We discussed this is the procedure what we followed. In detail we have been discussed. So optimum what that we have to consider the approximation that we have been discussed in our last class. That means how many iteration we are going to consider. So we are going to discuss decimal to octal conversion. Here we consider the decimal number is your 1368, or you can say 1368. Before I am going to discuss how to convert this decimal number to octal, first we have to know what is so called your octal number system. Here octal number system means 8 numbers. That means 0, 1, 2, 3, 4, 5, 6, 7. These are 8 numbers. Okay, so these are the basic 8 numbers belongs to the octal number system, right? So we have to start the conversion of this decimal number. So as we divided the two for conversion decimal to binary, here decimal to octal conversion we have to divide 8. So here we have been divided 8 with this number. This number is called as your dividend, and this 8 is your divisor, and this 171 will be your so-called quotient, and here we can get the remainder 0. This is your remainder. This is the remainder. So here each time we have to divide 8 until we are going to get this number, either 1 or 2, 3, 4, 5, 6, 7. Okay, so here we divide first 8 and we got 171 is your quotient and remainder 0. Next again the same step, divided by 8, we can get 21 is the quotient and remainder will be 3. Again we have to divide by 8, the quotient will be 2 and the remainder will be 5. So here the quotient we found 2. What I told, either one of these number we have to get, there we have to stop. Okay, so here we got 2 is the quotient. So this is our final step. Now we are going to consider from this side, from bottom to top, to write the octal number of this decimal number 1368. So finally this decimal number 1368 is subscribed by 10 converted to octal number as here 2530. 2530. Here 8 is your subscript, means this number indicates that this is the octal number of this decimal number. Okay, now we are going to verify this octal number is the decimal is the octal number for this decimal number or not, or we are going to convert this octal to decimal. Okay, here I written the same heading, octal to decimal conversion. We consider this one 2530 octal number. So how we are going to convert this octal number to decimal? Here you can see this is the LSB, least significant bit, most significant bit. Least significant bit will be multiplied by 8 to the power 0. In case of your binary, may you remember it was multiplied by 2 to the power 0. Least significant. Okay, multiplied with 8 to the power 0. Then second least, that is your 3, will be multiplied with 8 to the power 1. Then 5 will be multiplied with 8 to the power 2. Then 2, that is your most significant bit, will be multiplied by 8 to the power 3. Here starts from 0 and increases 1 by 1 increases. Okay. Okay. But in case of a binary, you remember it was how 2 to the power 0 multiplied again 2 to the power 1, like that. Now we have to just add these things, these values. 2 into 10, 8 to the power 3, 5 into 8 to the power 2, 3 into 8 to the power 1, and 0 into 8 to the power 0. If I'll add, and we can found 1368. Okay, same number what we considered over here. So this octal number converted to the decimal number, the decimal number is corresponding decimal number is 1368. Okay. Okay. Now we are going to go for fractional decimal to octal conversion. Here we considered a fractional number, that is your 1368.65. Just before we have been discussed decimal to octal conversion of 1368, and its value we found 2530 octal number, right? Here 1368 corresponding octal number is your 2530. Now our work is to find out the octal number of this decimal number 0.65. So what is the procedure we have to follow? This is the procedure. The procedure is the fractional part will be, here fractional part is your 0.65, will be multiplied by 2 each time until integer part come as 7 and fractional part will be come as 0, where integer part taken as answer. If 7 not came after 5 to 6 time iteration or multiplication, then we have to take optimum iteration or multiplication or approximation. You can see this is the same procedure what we considered for fractional decimal to binary conversion is same. In case of binary, we consider that each time it will be multiplied by 2. The fractional part will be multiplied by 2 each time. Here it will be multiplied by 8. In that case, we consider that here the integer part will become as 1 and the fractional part come as 0. Then we have to stop the iteration, but here we have to consider 7 and 0. Okay, so let us start to find out this fractional number, decimal number, its corresponding octal. So what we have to do, we consider this one 0.65 multiplied first 8, we found 5.2. So in 5.2, 5 is your integer part and 0.2 is the fractional part. Okay, so here we not got the 7, but this is the answer. 5 is the answer, integer part taken as the answer separately and written over here. Then 0.2 again multiplied with 8 and we can get 1.6. Here 1.6, in 1.6, 1 is your integer part, 0.6 is your fractional part. Here we not got the 7 and the fractional part not got 0, but this 1 will be taken as the answer for this step, written separately. Again 0.6 will be considered for the next multiplication 8. So here we consider the 2 iteration. We are going to check that it is approximate to value or not. So for this 2-step iteration, the answer will be here from top to bottom. We are going to consider top to bottom 5 1. That means here 0.65 decimal number converted to octal number by 2-step iteration. By 2-step iteration, we found corresponding octal number is your 5 1. So the answer will be this one, 2530.51. This 2530 represents the octal number of this decimal number 1368, and this 0.51 represents the octal number of 0.6165. Now we have to validate this reverse. If we are going to convert this octal number to binary, then we are going to get this number or not. Okay, so for that I given the heading over here. In the right hand side you can see fraction octal to decimal conversion. Here we considered what, 2530.51 octal number. Now we are trying to convert this one to a decimal. Here 2531, if I am going to convert octal number, if I am going to convert, the decimal number will be this much. Already we have been discussed in our previous slide. 1368, these things already verified. Only we have to verify this much. 0.51 will be, if we are going to convert, that will be 0.65 or not. Okay, so for 0.51 we considered like this, written like this. 5 will be multiplied with 8 to the power minus 1. 1 will be multiplied with 8 to the power minus 2. These two terms will be add up. By solving these two terms, we can found the value will be 0.6406 or approximate to 0.65. So this value can be acceptable as our answer, right? Here we can consider another third step itself, but with this two-step iteration, we also found the approximate value 0.65. Here we got 0.6406. It also can be acceptable. Okay. So finally, what we have been verified? We have been verified that this octal number converted to decimal, and the decimal number is 1368.65. Okay. So this has been verified. So here I am going to stop this lecture, today's lecture. In our next lecture, we are going to discuss octal to binary conversion and vice versa. Thank you so much for watching this video. Thank you.